Hello everyone, this video is about the demonstration of SAS miner with the sample dataset. So I took the dataset from the UCI machine learning repository, which is the German's Deutsche Bank credit data. So this data consists of 20 variables and around 1000 observations. So looking into the data set, uh, we have 20 variables which are the status of the checking account in that bank, and the duration, and the status of the saving accounts in the Deutsche Bank, and the personal status, whether it's married or single, and the age in years, property, job, telephone, and foreign worker. So the target variable is the class. So we classify the people in this bank to two categories. One is that they are good with the good credit risk, and other guys with the bad credit risk. So this is SAS manner where I did the diagram clearly, and I explain the steps to do the diagram. So we can edit the variables where we have to select the target variable. So I took class as a target variable, which is a good or bad credit risk. So going to the stats explorer. So in the stat explorer, we're going to see the insights of the dataset. So let's look into the results of the stat explorer. So we have the various plots, which are t-square plot and the variable worth plot. Seeing the output file, we have the different categories: binary, categorical, and numerical, which gives a count of the binary variables and the levels. And going through, we can see the different variables with the levels, and there's no missing data in this data set, so it's a clean data set. So the next step, we do the data partition, which we divide the data set into training, validation, and this data set. And the next is a control point. The main function of the control point is to do the different models with that same data set. So the next step is to build the decision trees for the data set. So there are some options in the decision tree to select this branch and leaf size, and also depth of the tree. So we select the required options for the decision tree and run the decision tree. So let's look into the results of the decision tree. These are the results where it has some statistics here, the plots here, and we have some output new statistics like gain, lift, and cumulative lift in this tree, and we have the tree itself. So let's look at the tree. So tree here, see the first classification done on the checking status. So the checking status is the main thing for the predicting the good or bad risk factor in this data set. So, and also the duration. So the how much duration is the checking out is in their bank, and also the amount, the credit amount they has in their bank. So all this is a main factor for the good or bad credit risk factor. So as you go up the tree, see here the good is 85%, and now it's 69. So it's keep on decreasing as the factors go on increasing uh, for the data set and the decision tree. So let's look into the another decision tree, which is interactive decision tree. So here when we select the split node, you can select which variable you want to classify the uh, data set. So you can select within, suppose you select housing, you can apply. You can see there's two types of own or rent. Is you can see there's a classification, and you can select the some housing, and you can select the age and apply. So here, so that the main advantage of this is you can do your own classification tree with this interactive decision tree. Now let's go to the neural networks. The neural networks, we have the different options. See the results of the neural network. So going to the result, we have the different plots here. The one is a cumulative lift gain. You can select whichever one and see the plot changing. And here you can see there are 50 iterations, and there is a graph between the average, square error, and the iterations. So looking into the output of the neural network, so these are some statistics we can see. So here are the different parameters. So here we can see the HI1, which is hidden level 1, and here level 2 for the different variables and the parameters present in the data set. As we move on, we have different statistics, and you can see the classification table. It's like a confusion matrix where we estimate a good, we got good, which is 83% correct. So, and when compared to the bad, we issued bad, we got good for 16%. So basically this classification table tells us the accuracy of our model that we built in the SAS miner. So we built more models and compared them, and we take the best one which fit the data set.